that feeling when you reach out and just press the power button on a machine?
Oh, yeah, like that little click.
Right, exactly.
Yeah.
You expect this pure, just unadulterated execution of engineering. It's binary, right?
Yeah, electricity flows.
Electricity flows, logic gates open or close, the boot sequence fires, and the machine just, does what it's built to do.
It's completely predictable.
It is. And it's comforting because, we like to think of our technology as this completely neutral terrain. Just raw math and physics, executing commands in a void.
Yeah, completely divorced from, human messy reality.
Exactly. But then you step into the text we are unpacking today, and suddenly that simple power button is, well, it's no longer just a mechanical switch.
Not at all.
It becomes a portal into this intensely philosophical, fiercely debated, and honestly highly political battlefield.
It really is. We're looking at a technological landscape that's mapped directly onto basically the survival, the hierarchy, and the very structure of human civilization itself.
Yeah, it's wild. So today we are doing a deep dive into an incredibly provocative text. But before we get into the weeds, a quick reminder to like and subscribe to the show, whether you're watching or listening.
Please do.
We're reviewing a truly fascinating new ebook today. And if this discussion hooks you, we highly encourage you to check Amazon Kindle and Google Play Books to buy it. And definitely make sure to follow the author at Conrad Riker at Substack.
Yeah, you'll want to follow up on this one because Conrad Riker's 2026 release, it's called Boot Order Startup Sequences, and the hierarchy of being it just demands your full attention.
It really does.
This is a text that takes the technical history of early computing, right?
Yeah.
Specifically, the genesis of the IBM PC standard, the granular intricacies of processor architecture.
All that deep hardware stuff.
Exactly. And the foundational rules of early network protocols. And it maps all of that directly onto right-wing political philosophy.
Right, and we should definitely set the table clearly for you right now regarding the context of this book. Riker is explicitly writing for a red-pilled men's rights activist audience.
Yeah, he's speaking directly to the manosphere.
He is. His core argument is that these early technical systems reflect what he calls a Western patriarchal will to power. He claims they represent an uncompromising natural hierarchy that, in his view, modern society has completely lost.
Which is a heavy premise.
Very heavy. So, as your guides on this deep dive, our mission is to do what we always do. We're taking a dense, controversial text and impartially reporting on the mechanics of its arguments.
We aren't here to endorse or, validate the highly charged political viewpoint.
Right, not at all. We just want to help you understand his intricate analogies. Riker is trying to explain the history of our institutions before they were, in his words, captured by feminists and Marxists.
And he's literally using the motherboard to do it.
Which is just a totally unique lens, right? Whether you find his conclusions brilliant or abrasive, he forces you to look at the invisible architecture running our modern world and see it as a mirror reflecting our deepest societal conflicts.
Yeah, so if you've ever wondered what a 1980s microprocessor has in common with ancient Roman law,
or how the power supply unit inside your desktop relates to modern corporate culture.
Right. This is going to completely change how you view the machine sitting right there on your desk.
Sure. So we have to start where Riker builds his foundation. August 12, 1981, Boca Raton, Florida.
The release of the IBM 5150.
Yep. And for anyone who follows tech history, we know this as the moment the personal computer transitioned from a hobbyist toy to a ubiquitous business tool.
But Riker looks at Don Estridge and his team of engineers and sees something almost mythic.
How does he describe them?
He says they were armed with nothing but silicon, solder, and an uncompromising will to dominate nature.
Wow.
Yeah, he calls the creation of the IBM PC the Prometheus fire of the 20th century.
That's quite the pedestal.
It is. But the critical angle Riker takes is how he contrasts the development of the 5150 with how things are built today.
Right.
Because in modern tech, we hear constantly about psychological safety.
Oh, yeah. Designed by committee, flat architectures, consensus-driven engineering.
Exactly. And Riker argues the IBM PC was the exact antithesis of that. He labels it an autocracy of engineering excellence.
Meaning Don Estridge wasn't holding town halls to ask how his engineers felt about the bus architecture?
Definitely not. He was making decisive, hierarchical commands to force order onto what was an incredibly fragmented industry at the time.
Because before IBM stepped in, you had the chaotic S100 bus systems, CPM machines just kind of doing their own thing.
Apple doing another.
Right, it was tribal.
Huh.
And Riker draws a direct parallel between IBM's autocracy and Roman law, the Lex Romana.
Yeah, he argues Rome thrived because it imposed a universal, rational legal framework upon chaotic tribal barbarians.
And in his view, IBM did exactly the same thing to the Wild West of early computing.
Exactly. Their bus structure, the BIOS, the interrupt controllers, these basically became the immutable computing law. He literally refers to it as the Judeo-Christian ethical legalism of standardization realized in hardware.
That is such a wild phrasing. But okay, IBM wasn't just building a machine, they were establishing the physics of a new universe.
But here's where it gets tricky for Riker, because he has to confront one of IBM's most famous tensions.
Right, the open architecture. IBM intentionally published its complete source code and hardware schematics for the PC.
They put the BIOS assembly code right there in the technical reference manual for literally anyone to read.
Which is where his framing gets really fascinating for me. Because modern tech historians universally frame that decision as an early form of open source egalitarianism.
Yeah, it's usually taught as a communal, almost democratic act of sharing knowledge.
Like, if I give away the deepest architectural secrets of my hardware, I'm fostering community. But Riker absolutely rejects that, doesn't he?
Oh, totally.
So how does he square giving away the blueprints with this aggressive patriarchal will to dominate?
Well, he goes on the offensive against that historical narrative. He calls the open source egalitarian interpretation a gynocentric feminization of history.
Wow, okay.
Yeah. To Riker, publishing those schematics wasn't charity. It wasn't community building. It was an act of supreme patriarchal confidence.
He uses the metaphor of an emperor, right?
Yes. An emperor doesn't hide his architectural drawings because he's terrified the peasants might copy his castle.
Right. He nails the blueprints to the door of the town square as an open challenge.
That's the exact psychology Riker is tapping into.
Yeah.
IBM owned the architecture. They wrote the rules of the road. By publishing the schematics, they were essentially daring the rest of the world to try and operate within their kingdom.
They invited vassals to build upon the king's domain because they were just absolutely certain they were the apex predators.
They had the capital, the supply chains, the engineering rigor. They knew the smaller players lacked the capacity to actually surpass them.
So it wasn't about sharing at all. It was about defining the arena and forcing everyone else to fight on their turf. Which perfectly sets up the entry of Compaq in 1983. Because Compaq didn't just play in the arena, they effectively used the rules of the arena to challenge the king.
Yeah, the famous clean room reverse engineering.
Right. To build a machine that was 100% compatible with the IBM PC without, triggering copyright infringement, they couldn't just copy IBM's proprietary BIOS code.
No, the legal peril there was massive. If a single variable name or unique structural quirk from the IBM BIOS showed up in Compaq's code,
IBM's lawyers would have annihilated them.
really.
So they separated their engineers into two isolated teams. Team A read the IBM BIOS manual, studied its inputs and outputs, and wrote functional specifications without writing a single line of actual code.
Right, just dry specs.
Yeah, and then they handed those specs to Team B, who were engineers who had legally sworn they had never looked at the IBM code.
And Team B built a brand new BIOS from scratch that behaved identically.
It's a legendary maneuver, but you'd think Riker would view Compaq as rebels, tearing down the hierarchy, dismantling the king's monopoly.
You might assume that, but he spins it entirely differently. He views Compaq as the ultimate expression of rational, red-pilled masculinity.
How so?
Because notice what Compaq didn't do. They didn't complain to the government about IBM being an unfair monopoly. They didn't protest.
They didn't demand the standards be lowered so inferior machines could compete?
Exactly. They submitted to the superior standard. They bowed to the Lex Romana of computing.
Oh, I see.
And that's the crux of his philosophy on competition. They acknowledged the hierarchy, but they utilized Aristotelian logic, exacting legal rigor and sheer intellectual torque to beat the king at his own game.
So proving that the hierarchy works.
Right. Riker calls this the supreme-based reality of the free market. Compaq proved that strict hierarchies don't oppress competence, they reward mastery.
And he turns this into a very direct directive for you, the reader. He's telling you to stop relying on what he calls the modern gynocentric state to provide for you.
Or to lower the bar for your success.
Right. You have to master the immutable laws of reality, secure your own property, and conquer the standard through absolute competence, exactly the way Compaq did.
It's a really remarkable pivot from corporate history to raw personal accountability.
It is. And to drive this point home, Riker doesn't just stay at the macro level of corporate legal battles. He drills all the way down into the literal microscopic components of the motherboard.
To prove that hierarchy isn't just a social construct, right?
Exactly. He says it is mathematically inescapable at the silicon level.
Which takes us into his analysis of hardware determinism, specifically the interrupt hierarchy.
Right, let's talk about that. We all know the basics of how a central processing unit works. It's a finite resource.
Right. Even today, at its core, a processor core executes one instruction stream at a time.
But you have all these asynchronous hardware devices, right?
Yeah.
The keyboard, the mouse, the hard drive, the network card, they're all firing off requests for attention simultaneously.
So Riker focuses on the Intel 8259A programmable interrupt controller, the PIC.
The ultimate gatekeeper.
Because if the CPU tries to listen to all those peripheral devices at once, what happens? You get unmitigated chaos.
The system crashes.
Exactly. Riker writes that a processor attempting to service all devices equally out of, quote, pathological altruism would produce pure garbage.
There is no equality of interrupts in silicon.
None. There must be a strict, ruthless ranking determining which request is serviced first.
So he looks at the IRQ lines, the interrupt request lines, and he zeroes in on IRQ 0.
Yeah, and for those who have ever had to manually resolve an IRQ conflict back in the day, IRQ 0 is untouchable.
It's the system timer.
Right. Riker elevates IRQ 0 to an almost theological level. He calls it the logos of the machine, the fundamental heartbeat that structures the entire system.
Because, think about it, if the system timer isn't serviced, nothing else matters.
The concept of time within the computer literally ceases to exist. A keyboard press or a hard drive read becomes meaningless if the system doesn't know when it happened.
And this is where his analogies get incredibly dense, because he maps this microscopic hardware ranking directly onto medieval theology.
Augustine of Hippo, right?
Yes, specifically Augustine's concept of ordo amoris, the order of love.
Right, so Augustine argued that human beings must properly order their loves. You cannot serve a higher transcendent purpose unless your lesser, worldly attachments are strictly subordinated.
And kept in their proper place. Like, loving your family is good, but loving a physical comfort more than your moral duty is a disordered love, and it leads to sin.
And Riker applies this straight to the CPU's assembly stack.
It's a crazy leap, but it makes sense in his framework.
Yeah. When a higher priority interrupt comes in, say IRQ1 from the keyboard, the CPU pushes its current, lower priority task onto the stack.
It essentially pauses the lesser task, saves its state, addresses a higher calling, and only then returns to where it left off.
He calls the stack the mechanism of sacrificial memory.
Which is honestly a beautiful way to describe basic computer engineering. But Riker isn't just waxing poetic, he's giving the reader operational orders here.
He's saying you must act as your own 825-9 programmable interrupt controller.
You must program your own internal boot order.
Right. Which, how is a listener supposed to apply a microchip's interrupt request line to their own daily life?
I love this analogy, frankly. It's like a cognitive triage or a pre-flight checklist for your life.
Right.
If you sit down and map out the demands on your attention, what is your IRQ 0? Riker says your God-given purpose, your deepest calling, must be mapped to IRQ 0.
It always fires. It always gets service, no matter what else is happening.
Exactly. Your family obligations might be IRQ 3. Your mission-critical work is IRQ 1.
But then he turns a harsh light on the noise of modern life. Where do social media notifications rank?
He places them at IRQ 7, the absolute lowest of the low, near background static.
The 24-hour news cycle outrage. Maybe IRQ 6?
His point is devastatingly simple. If you treat an IRQ 7 background task like an IRQ 0 imperative, your life's operating system crashes.
Right. If you let a Twitter argument interrupt your deep work, your internal hierarchy is fundamentally corrupted.
He even brings specific processor commands into the metaphor, like the CLI command. Clear interrupts.
Yeah, in assembly language, when a CPU executes CLI, it literally masks or ignores all maskable interrupts. Nothing can get through.
And Riker frames this as the ultimate state of deep work. When you are engaged in building your empire or focusing on your core purpose, you must execute a mental CLI, shut off the phone, mask all lower interrupts.
But the hardware has exceptions, and Riker integrates those as well. The NMI?
The non-maskable interrupt.
Yeah. In physical hardware, an NMI is catastrophic. It's a memory parity error or an impending power failure. You cannot ignore it, even if you've executed the CLI command.
The CPU drops absolutely everything to handle the NMI.
Because if it doesn't, the machine physically dies.
Exactly. And Riker maps this to real-world emergencies, a house fire, a medical crisis, a child in physical danger. Those are true NMIs.
And his critique of modern culture hinges right here. He argues that modern, what he calls female-coded culture, attempts to elevate every minor inconvenience to NMI status.
Every offensive comment, every perceived microaggression is treated as an absolute crisis that demands the entire system's immediate attention.
His takeaway there is incredibly stark. He says, when everything is an emergency, nothing is.
Right. If you don't fiercely rank your values, the world will happily rank them for you, and it will keep you bogged down servicing IRQ-7s until you die.
It's a very Hobbesian, zero-sum view of attention management.
Totally. And this theme of managing finite resources logically brings us to Riker's profound respect for physical boundaries.
Which is fascinating. He looks at the literal memory constraints of early hardware and contrasts them sharply with the software environments we live in today.
We're talking about the famous 640K barrier and what Riker calls the tragedy of infinite expansion.
Right. To understand his argument, you have to look at the Intel 8086 processor, released in 1978. It was a 16-bit processor.
And we know the math on that. A 16-bit register can only address 65,536 bytes of memory. 64 kilobytes.
Which, by today's standards, that's not even enough memory to open a single high-resolution image, let alone run an operating system.
Right. But the engineers at Intel knew 64K wasn't going to cut it for serious computing. They wanted to address a full megabyte of memory.
Which requires a 20-bit address space.
So they have these tiny 16-bit registers, but they need to feed 20 physical pins on the chip to reach that megabyte.
The mechanism they designed to solve this is called segment offset addressing, and Riker is just obsessed with it.
Because it's amazing. It's like trying to MacGyver a massive V8 engine out of two tiny four-cylinder engines using nothing but raw math and perfect timing.
Exactly. Instead of just accepting the 16-bit limit, they took the value in one 16-bit register, the segment register, and logically shifted it to the left by 4 bits.
So in hex, that's like adding a 0 to the end, effectively multiplying it by 16.
Right. Then they took a second 16-bit register, the offset, and added it to that shifted segment value.
So by doing this overlapping, sliding math on the fly, millions of times a second, they conjured a 20-bit physical address out of purely 16-bit parts.
And Riker describes this segment offset scheme as a masterclass in masculine genius. He points out that the engineers didn't complain to the universe about their limitations.
They didn't demand that the laws of physics change,
No, they used raw intellectual torque to build a bridge over the limitation.
which naturally leads to one of the most famous or, infamous quotes in tech history, the myth that Bill Gates said 640K ought to be enough for anybody.
Oh man, Riker aggressively attacks that myth.
I mean, Gates has repeatedly denied ever saying it, noting that anyone who actually understood computers at the time knew memory demands would continually scale.
But Riker takes it a step further. He claims the persistence of the 640K is enough. Myth is a deliberate weapon of the left.
A weapon of the left, that's a massive leap. How does he justify that?
He argues it's a retroactive attempt to smear the patriarchal founders of computing as arrogant, short-sighted, and out of touch.
I see.
He thinks modern tech historians use that fake quote to view these foundational architects not as men who conquered physical limits, but as flawed targets to be torn down by an egalitarian mob.
So he's fiercely defensive of this era of memory constraints because, in his philosophy, scarcity forces innovation, and innovation builds character.
Exactly. The DOS era was a time of supreme discipline. When you only have 640K of base memory to work with, you can't be lazy.
Right, every single line of code, every variable, every TSR program loaded into high memory must justify its existence.
It forces the programmer to be utterly efficient, to understand the hardware at a microscopic level, and
Yeah.
to take personal responsibility for every byte of RAM they consume.
And Riker contrasts this directly with modern software development, which he characterizes in highly political, polarizing terms.
Yeah, he compares modern bloated software to a feminist welfare state.
What?
His core argument is that modern developers operate on a delusion of infinite resources. They assume infinite RAM, infinite cloud storage, infinite safety nets.
And because they don't face strict boundaries, they produce sluggish, inefficient, bloated applications built on layers and layers of abstracted code they don't even understand.
And he claims this technical bloat perfectly mirrors leftist socioeconomic policies that demand limitless debt, expansive safety nets, and constant growth, while completely refusing to acknowledge the physical reality of economic scarcity.
So his advice to you is to embrace the limits.
Right. True sovereignty doesn't come from demanding the universe accommodate endless expansion without consequences.
It comes from acknowledging harsh physical and economic realities and building your empire within those unforgiving boundaries.
What's really striking is how seamlessly he transitions from the limitations of the hardware to how human beings are actually allowed to interact with that hardware.
Yeah, if the machine is bound by these rigid mathematical laws, what is the proper way for a user to interface with it?
This leads to Riker delivering one of the most fiery, uncompromising critiques in the entire book when he tackles the user interface.
He pits the command line interface directly against what he calls the Macintosh heresy.
Heresy is a very deliberate religious word choice. He is framing the 1984 Apple Macintosh not as a technological evolution, but as a moral failing.
Let's ground this in the experience of the DOS command line. You boot up the PC, and what do you get? A black screen and a blinking cursor. The C prompt.
It sits there entirely passive.
Right. It does absolutely nothing until you tell it exactly what to do using precise syntax. Riker describes that blinking cursor as the logos itself.
He says it demands intelligence, competence, and precision. It's a language of unvarnished truth where a single misplaced backslash means total failure.
And he views the CLI as the supreme expression of Western logical inheritance. You must meet the machine at its level.
You have to understand the directory structure, which he likens to Aristotle's great chain of being. Everything has its strict patriarchal place in the file system.
The machine doesn't guess your intentions. It doesn't auto-correct your thoughts.
No, it executes exactly what you command, and if you command it to delete the system files, it obeys without judgment. It's a relationship based purely on mastery and accountability.
But then 1984 happens. Apple releases the Macintosh. And we all remember the Ridley Scott Super Bowl commercial framing the Mac as this colorful, liberating, hammer-throwing rebellion against the drab, authoritarian world of IBM.
Riker absolutely despises the Macintosh.
He labels the graphical user interface, the GUI, as a force of domestication.
Instead of typing precise literate commands, you are suddenly clicking on cute pictures of folders and trash cans.
Right. He views the GUI as a mechanism that lowers the machine to the user's level, replacing strict logic with feelings and literacy with mindless clicking.
He calls the early Macs a closed, paternally sealed, beige box.
Which, historically, that's true. Steve Jobs famously didn't want users opening the case. He used proprietary screws.
Contrast that with the IBM PC, where you were expected to pop the hood, swap out expansion cards, and physically engage with the motherboard.
But I have to challenge Riker's philosophy here from a basic user experience perspective.
Sure.
Isn't removing friction the entire point of technological progress? Like, if a GUI allows millions of people to use computers who otherwise couldn't, doesn't that democratization make society vastly more productive? Why is friction inherently a virtue?
It's the obvious counterargument. But Riker anticipates it and attacks it by introducing what he calls the quality control fallacy.
What's that?
He argues that removing friction is fundamentally destructive to the user's immune system.
The immune system of the mind.
Yes. His premise is that a man who never faces resistance grows weak. By treating users like infants who need bright colors and simple icons, Apple created a culture of technological hatelessness.
So the modern user no longer understands how the machine works. They only know how to consume what the interface feeds them.
Riker argues that the harsh, high-friction environment of the command line acts as a Darwinian pressure. Bad code dies. Weak users are forced to learn.
The open standard builds competence because it demands it.
Exactly. So a closed system creates a dependent user base, while an open, high-friction system builds an autonomous, competent user base.
It's fascinating because he's essentially saying that making things easier makes us worse.
And his call to action for you is to audit your own life for walled gardens.
Walled gardens.
Yeah, where have you surrendered your autonomy in exchange for comfort? Are you trapped in an ideological echo chamber? Are you reliant on a closed financial ecosystem that can cut you off if you violate their terms of service?
So he urges you to break those walled gardens down, demand the interoperability and autonomy of an open standard, run your life on open source principles, and refuse to submit to the coddling tyranny of a curated environment.
It's an intense, almost stoic approach to technology.
Yeah, very stoic. But this philosophy of embracing limits and demanding high friction assumes that the hardware itself is sound. What happens when the physical laws Riker reveres are flawed out of the box?
Or when the machine demands raw power to function.
Right. This brings us to what Riker calls motherboard philosophy, where he examines the POST sequence, the 1994 Pentium FDIV bug, and the literal electricity running through the power supply.
Let's look at the power on self-test, the PST.
Yeah, explain how that fits in.
So before an operating system is even loaded, the BIOS runs a series of hard-coded diagnostic tests. It checks the base memory, verifies the video output, pings the keyboard controller.
And if something is critically wrong at the physical level, it gives you a series of harsh beeps and halts the system. It refuses to boot.
And Riker uses the POST sequence as a metaphor for societal moral foundations. He argues that a central processor must systematically verify that its physical hardware exists and is functioning before it hands control over to high-level software.
And he applies this directly to modern society. He claims that leftist culture constantly broadcasts its virtue through high-level software. Political slogans, emotional protests, social media activism.
While completely ignoring the corrupted state of its foundational hardware.
And he points to biology, economic scarcity, and the nuclear family as that foundational hardware.
His argument is that if your foundational memory is corrupted, no amount of virtue signaling in your software will prevent a catastrophic system crash.
The machine simply won't boot. You cannot run a complex, thriving civilization on a framework that fails to acknowledge its own physical reality.
And this absolute insistence on physical objective truth leads into his brilliant analysis of the 1994 Pentium FDIV bug.
Right. For those who aren't familiar, this is a legendary moment in tech history. A math professor named Thomas Nicely was doing complex prime number research, and he discovered that the newest Intel Pentium processors were returning slightly incorrect answers when dividing certain specific floating point numbers.
It wasn't a software glitch, it was a hardware flaw, baked right into the physical silicon logic arrays of the floating point unit. So entries in the lookup table were literally missing.
And how Intel initially handled this crisis is what draws Riker's absolute ire.
Yeah, because when Nicely went public, Intel didn't immediately issue a massive recall.
Instead, they tried to manage the PR narrative. They minimized the issue. They put out statements claiming the flaw would only affect highly complex scientific modeling, and that the average spreadsheet user would never encounter it in 1,000 years.
They even set up a system where they would only replace your chip if you could prove to their customer service reps that you needed highly accurate math.
Which is an astonishing stance for a microprocessor company. Our calculator is fundamentally flawed, but you don't really need a perfect calculator, do you?
Riker uses this as the ultimate example of what he calls a feminine strategy of social reality manipulation.
He argues that postmodernism and leftist ideology operate on the premise that if you can control the perception of reality, you control the outcome.
If Intel's PR department declares a flawed chip acceptable, they believe it becomes acceptable.
But objective reality didn't care about Intel's press release.
Not at all. Riker points out that the processor exposes every mathematical error with merciless precision, without any emotional mediation.
And the market reacted violently. IBM, acting as the enforcer of objective truth, publicly announced they were halting all shipments of Pentium-based computers.
They recognize that any error rate in a CPU is unacceptable for serious business.
IBM brought the hammer down. They refused to play along with the PR manipulation. Intel's stock tanked, and they were forced to issue a humiliating apology and offer a sweeping, no-questions-asked replacement program.
For Riker, this proves that reality enforces its own verdict. No amount of narrative management, no amount of PR spin can fix a physically broken logic gate.
Right. And from the objective truth of logic gates, Riker makes a really fascinating leap into electrical engineering.
He looks at the computer's power supply unit, the PSU, and he breaks it down into two specific pathways: the 12-volt rail and the 5-volt standby rail.
This might be his most structurally intricate and controversial metaphor.
It really is.
I found this analogy incredible, because in a standard ATX power supply, the 12-volt rail provides the heavy-duty power. It drives the CPU, powers the graphics card, spins the hard drive motors.
It is the high-voltage muscle of the machine.
And Riker associates the 12-volt rail with raw logic, IQ, Newtonian physics, and the driving force of progress. It represents the masculine imperative to conquer natural limitations through high-stress, high-output effort.
But then he contrasts it with the 5-volt standby rail.
What does that do?
The 5-volt standby rail provides a continuous trickle of low-voltage power to the motherboard, even when the computer's physically turned off.
Ah, so it's what allows a network signal or a keyboard press to wake the machine up.
Exactly. It keeps the system in a dormant, submissive, ready-to-serve state.
And here's where the leap to human psychology happens. Riker equates the 5-volt standby rail to EQ, emotional intelligence.
He brutally deconstructs EQ, viewing it as a passive, subservient metric. He claims the modern corporate obsession with EQ, safe spaces, and trigger warnings is a deliberate, systemic attempt to step down the voltage of society.
By prioritizing emotional comfort, the 5-volt rail over raw, uncompromising intellect and ambition, the 12-volt rail, he argues society is intentionally keeping men docile and compliant to a gynocentric consensus.
By valuing empathy over raw capability, society is effectively putting its most productive members into sleep mode.
So he challenges you right now to audit your own life's voltage.
Are you coasting on the 5-volt standby rail, prioritizing comfort and avoiding friction?
He urges you to reject the safe, corrupted voltage of consensus and intentionally introduce high-stakes, high-stress challenges back into your life. Run your existence entirely on the 12-volt rail of objective truth and physical mastery.
It's a relentless demand for high output.
It really is. And once he has established this rigid, high-voltage, uncompromising philosophy for the individual machine, Riker finally scales his vision out to the macro level.
What happens when millions of these machines connect to each other in an unregulated void?
We enter the digital state of nature.
And to illustrate this, Riker focuses on November 10th, 1988, and the release of the infamous Morris worm.
Yeah, this was the first major coordinated piece of self-replicating malware to hit the digital frontier. A graduate student named Robert Tappan Morris Jr. released a tiny piece of code that exploited vulnerabilities in early Unix protocols.
It utilized a debug backdoor in SendMail and a buffer overflow in the Finger Daemon.
And within 24 hours, it infected roughly 10% of the entire internet at the time, bringing massive university and military systems to a grinding halt.
What's crucial here is that Morris claimed the worm wasn't meant to be destructive. It was an experiment to map the size of the internet.
But it had a flaw in its replication code. It would ask a computer if it was already infected, and even if the computer said yes, the worm was programmed to infect it anyway 1 out of 7 times to prevent systems from faking immunity.
Which caused infinite loops of reinfection, crashing the servers.
And Riker views the Morris worm not just as a technical failure, but as a philosophical reckoning.
He examines the early internet protocols like FMTP for email or Telnet for remote access. These protocols were built by a small, high-trust community of academic researchers.
They assumed that anyone connecting to the network was a trusted colleague acting in good faith. Telnet literally transmitted passwords in plain text across the open network because it assumed no one was maliciously listening.
Riker calls this the original sin of academic naivete. It assumes human goodness is the default state.
It's like leaving your front door wide open, your safe unlocked, and your car keys in the ignition because you assume everyone walking down the street is a trusted friend.
Exactly, and Riker maps this directly onto leftist political theory. He compares the naive protocols of the early internet to open border policies.
He mocks the belief that human malice is just a byproduct of exclusion or misunderstanding, rather than a permanent dark feature of reality.
The Morris worm proved, in real time, that when a network is ungoverned and operates on universal trust, it immediately defaults to a Hobbesian state of nature.
Thomas Hobbes, the war of all against all, where life is nasty, brutish, and short. Without a Leviathan to enforce order, cyberspace instantly became a war zone where survival required technical competence and aggression.
And the technological response to this Hobbesian reality was the invention of the firewall.
Which Riker celebrates with almost religious reverence.
He writes that the firewall is the exact point where reason becomes force.
Aristotle's logic might give you a valid argument, but a syllogism doesn't repel a barbarian at the gate.
The firewall takes the logical decision to exclude unauthorized traffic and implements it as physical reality in silicon. It doesn't negotiate.
It doesn't ask for the packet's lived experience. It doesn't dialogue.
No, it simply drops the unauthorized packet into the void.
And from this defense of digital borders, Riker zooms out to the absolute grandest scale. He looks at the entire by86 architecture.
The underlying instruction set that powers almost every PC and server on Earth today.
Right, and he calls it Indra's net.
Indra's net is an ancient Eastern philosophical concept of a cosmic web, where every node contains a jewel that reflects all the other jewels perfectly.
And Riker uses this to describe the inescapable legacy of the IBM PC standard. He points out that even today's most advanced AI supercomputers, those massive arrays of GPUs running trillion-parameter deep learning models, they still rely on by86-derived architecture to execute their foundational instructions.
The ghosts of the 1981 Boca Raton engineers are still dictating the flow of electricity today.
Even the artificial gods must bow to the legacy hardware drafted in the 80s.
He's an eternal, inescapable cosmic order.
And because this architecture is inescapable, Riker's final advice to you is about defending your position within it. He urges you to act as your own firewall. Defend your digital and intellectual homestead.
He tells you to stop renting space in the Google data graveyard, where massive corporations hold the kill switch to your digital life and your speech.
He advocates for extreme self-hosting. Build your own server on commodity hardware. Run Linux.
Use Nextcloud for your files. Run Plex for your media. Reclaim your digital land one machine at a time.
Own your hardware, own your data. Sovereignty cannot be rented.
It's the logical conclusion of his entire thesis. If the world is a hierarchy based on physical mastery, you must physically master the infrastructure of your own life.
We have navigated an incredibly intense, deeply uncompromising text today. Riker uses the raw mechanics of 1980s computing, from the ruthlessness of IRQ rankings to the 12-volt power rails to the unforgiving syntax of the command line, to construct a sweeping, fiercely right-wing manifesto for personal sovereignty.
He demands that his readers align their lives with the unyielding, objective physics of the machine, explicitly rejecting what he sees as the soft, consensus-driven illusions of modern society.
It is a remarkable synthesis of electrical engineering and political philosophy. By forcing us to look at the lowest, microscopic levels of our technology, he builds a framework to understand the highest levels of our societal conflicts.
And it leaves us with a final, provocative thought to mull over. Riker talks about the by-86 architecture as an eternal foundation. Subsequent generations must build upon it. They are unable to ever truly dismantle it without breaking the system entirely.
It raises a fascinating question about human societies. If our foundational civilizational code, things like Roman law, Western philosophy, the nuclear family, operates like a legacy hardware standard, are revolutionary attempts to completely dismantle societal structures doomed to cause a catastrophic system crash?
Can you ever truly rewrite society if you ignore the unchangeable legacy hardware of human nature?
It ultimately asks whether we are forever bound by the boot order of our biology and our history. You press the power button, the electricity flows, and the hierarchy boots up.
It's been quite a ride.
Thank you for joining us on this deep dive. As always, please remember to like and subscribe to the show. We highly encourage you to check Amazon Kindle and Google Playbooks to buy the book we discussed today.
And make sure to follow the author at Conrad Riker at Substack.
Until next time, keep exploring.